Hello, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to be continuing on with our discussion of circles, and we're going to look a little bit more closely at the properties and relationships between chords and arcs. So please copy down your title as well as your objective. Our objective for this day will be to learn the properties associated with chords and arcs and how they interact with circles. This is not going to take us very long. There's not very many properties that go along with them. Okay, but we are kind of taking the circles in small little pieces. There are a lot of properties. It's difficult to keep them all straight sometimes, so we're trying not to bite off too many at one time. As always, press pause anytime you need more time on the video, and then hit play when you're ready to move forward. Okay, now some of the definitions we're looking at today are kind of wordy. Okay, so just kind of pay attention. I'm giving you diagrams to go along with them. As always, you may want to color code some of these notes that you're doing with the circles, because it does make reference to a lot of items inside of the structures. Okay, first rule says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Now in a diagram, it would look something like this. Okay, and you can see on the left side a diameter, that's the red guy coming straight down north to south through the circle, passing through the center point. If that diameter is perpendicular to a chord, okay, obviously the blue guy coming left to right, he's the chord there, and it is marked as having a right angle between the two. Okay, so there's your hypothesis. If a diameter is perpendicular to a chord, then the conclusion is then the diameter bisects the chord as well as its arc. Okay, so you can see, well, you can't really see the coloring in there, but the little purple single tick marks on there show that the chord is bisected. And then we also have the ability to use tick marks on arcs as well. Okay, because technically an arc is nothing more than a bent line, so we can use tick marks on them just like we use on lines. So the double tick marks on the little two pieces of the arc there to show that it has been bisected as well. Another rule that we are looking at today says if a chord is a perpendicular bisector of another chord, then the first chord is a diameter. Now this is basically the converse of the rule that we discussed at the top of the page. Okay, instead of using the fact that we have a diameter intersecting a chord, okay, now we are that being causes it to be the bisector of the chord and the arc. Now we are using the fact that yes, we have a chord of some kind, which would be the red guy coming through the circle, and it is proven in fact to be a perpendicular bisector of a second chord, being the blue guy. Okay, when that happens, okay, again, we're flipping here, then the converse states that the line segment that did the perpendicular bisecting, that chord is in fact a diameter. So you can see on the right-hand drawing, now the chord passes through the center point of the circle, whereas in the left-hand drawing, we weren't sure if it passed through the center or not. There's one more rule that goes along with how chords and arcs behave inside of the circles. So let's take a look at it. And the rule says two chords will be congruent if they are equidistant from the center. Okay. This one's not exactly common sense until you really get to thinking about it. Okay, basically what we are saying here is if you have two chords in a circle and you measure directly to the center point of the circle from those two chords. And as you can see in the diagram on the left, measuring directly to the center would happen when you measure perpendicular, okay, just like you measure your height from the ground to the top of your head. Okay, you measure perpendicular from the ground. You don't measure at some kind of an angle off to the side. Measure straight up. Okay, so from the two chords that are in the circle, measuring directly to the center point of the circle, this rule is stating that if those measurements to the center point are congruent, that's why the tick marks are in there on the left, then that means that the chords themselves are congruent to each other. Over on the right side, you can see the line segments. The chords are now being marked with a tick mark for themselves. Okay. Now there are a couple of examples here. I think these rules are pretty straightforward, and I believe that you can probably work your way through. So I'm going to give you these examples, and I'm going to let you finish them on your own. Okay, so here is one. We have a circle that has two line segments in it. One of the line segments is a diameter, and they are perpendicular to each other. And then we have all kinds of measurements that are marked in the picture, some lengths of line segments, some arc measurements, things like that. And there are three variables, A, B, and C, to be found. So copy that down and see what you can figure out about what A equals and what B equals and what C equals. And then we're going to have another diagram that I want you to answer also. So press pause right now if you don't have this diagram down yet. The second diagram looks like this one. Okay, in this case, pardon me, in this case, we have a couple of chords existing in the circle together. We have information marked in the circle that these chords are equidistant from the center point, and we have a one chord measurement inside of the circle. We have an arc measurement outside of the circle, and two variables, x and y, that both need to be solved for. So copy this one down, see if you can figure out what x and y are doing as well. This will be the end of the audio. I will leave the video playing. If you haven't got this copied down, you'll have a few extra seconds. I do appreciate you getting your notes taken care of, and I will see you in class.